So I did number 11 on section 3.4, and this is a problem right over here, and it's asking you to find the inflection point. So first you'd find the second derivative. So you take the f prime of x equals 3x squared minus 12x minus 12, and you take the derivative of that, so it's 6x minus 12. And you set that equal to 0. So, and it's x equals 2. And then you create a number line with placing just 2 over here. And what I'm going to be doing is I'm going to be substituting values from this interval and seeing if it's positive or negative. So from here I'll be doing f double prime of 1. I'll be substituting into the derivative. So let's circle that. So f double prime of 1 is equal to negative 6. So that's a negative number. So it's negative over here. And then I'll be substituting 3. So f double prime of 3 is equal to positive 6. So it's a positive number. So I'm doing a positive number over here. And you know there's an inflection point at the point at x equals 2 because of concavity, because the second derivative changes from negative to positive at that point. You know there's a concavity change, which is where the inflection point occurs. So I'll be plugging in 2 into the original function to find the y value. So I'm going to be writing the original function over here. And f of positive 2 is equal to 8 minus 24 plus 24. F of positive 2 is equal to 8. So the inflection point is at 2, 8. And reversing a couple of steps, I know that the function changes concavity because f double prime here is from negative to positive. I know this is negative. I know the f double prime is negative because it is less than 0. I know that's positive because it's greater than 0 on this interval. So you would write the sentence, the function has an inflection point at 2, this would be a positive, at 2, 8, because f double prime of x goes from negative to positive at that point. So the function changes concavity. And the second part of the question asks you to discuss the concavity. So, as I said earlier, if f double prime of x is greater than 0, that means it's concave. Oh, so I can't see that. It's concave up. And if f double prime of x is less than 0, it's down. So you would know that on the interval, negative, so it's concave down. You know that on the interval negative infinity to 2, it's concave down because it's less than 0. Infinity to 2. And you know it's concave up on the interval 2 to infinity because it's greater than 0 on that interval. And to write it out all in sentence form, you would say, I'm using the example of concave up, you would say the function is concave up on the interval 2 to infinity because f prime of x is greater than 0.